we have another presenter in this session of visualization facilities, and I'd like to welcome Mr. Pedersen from Mechdyne Systems. Mechdyne has worked a lot with different types of VR delivery systems, and welcome. Thanks for being here.
Thank you very much. Yeah, some of you may have been expecting Kurt Hoffmeister to arrive, and he went and did something unexpected. He retired on us, and so we were very disappointed to see Kurt move on to fishing, for one thing. So in his place, you get me, so apologize in advance for not being Kurt. But we're going to talk about current visualization facilities trends and future considerations. We're going to try and work through this quickly at the beginning and spend more time on the what's next part. So we're going to talk about some commonalities among some visualization systems to start with. And some of these are going to be obvious. Many of you have worked with visualization systems. I was curious. I kind of took a quick glance when he asked how many people have not been in a cave. Very few of you have not been in a cave. So you guys are very familiar with some of the basics of a visualization system. Of course, you have to have a display. Visualization, kind of by definition, means you're looking at something. And so, one of the trends that we've seen is, of course, when we first started in this, and I've been doing this for 18 years now, of course, it was all rear projection displays. It was CRT projectors, and then, DLP projectors, and moving on from there. And we've seen a trend toward flat panel technologies for all the obvious reasons. It takes us much less space, and you'll, get some of those obvious benefits from that. In most cases, it's a stereoscopic display. Not always. Some visualization systems are just very high resolution 2D displays. But in many cases, you're going to have a stereoscopic element to it. And again, as I mentioned, the CRT to the stereo flat panels. And then there's this question mark, right? Are we headed back to projectors? If you've been paying any attention to the flat panel market, there is not a consumer flat panel available on the market today that I'm aware of that supports 3D. And so we're kind of back to projectors, and we're going to cover that more in a little bit. So in almost every case, you have some kind of positional tracking system. For one thing, you track the eyes so that you can have viewer-centered perspective, and also give you the parallax that has been mentioned several times. But as you move your head, and you're going to get that extra cues from the parallax as well as the viewer-centered perspective. And we've seen trends in that as well. Magnetic was what we were using at the early days. We were using Ascension, Polhemus, those types of brands. We moved to, at least for us personally as a company, we were moving to the acoustic inertial. The InterSense system was the system we used for a long time then as well. And recently, much of the positional tracking is optical. So ART and those types of companies. And of course, you need an image generator of some sort. We used SGI, like big rack computers were the image generators when we first got started. And it was an amazing experience to be working with those. And then we've moved to PC clusters was what we were using for a long time. And we still continue to use some PC clusters, but the trend now is to see if we can do it with a single PC with multiple GPUs. So if we talk about what some of the types of visualization facilities are, and these are very familiar to you. We have a fully immersive system. We might call that a cave in this case. It's generally speaking, it's a cubic type system that is rear projected or built on a flat panel technology of some sort, and you are able to fully immerse yourself into it. You would have a flat wall display. It would be a power wall would be a term commonly used for such an immersive type facility. And there's a couple of examples there. There's the C6 at Iowa State, which is a full 6-sided immersive system, which was a very exciting system. And there, the Beauty Lab at L'Oréal Paris, actually, they're using an immersive environment there as well to help them do marketing analysis for their L'Oréal products. A dome is another commonly used type of visualization facility. There's the California Academy of Sciences, the Morrison Planetarium. Now that would be a 2D only type solution in that particular case, but you could certainly make 3D dome systems as well. high-resolution 2D flat panel tiled walls. So I saw a big growth of those. NASA, of course, had Hyperwall. They had systems down at Cal IT Squared. They were very early on to take a large number of flat panel displays and array them up and create systems that were just very high-resolution 2D flat panel displays for a visualization type system. You might have a reconfigurable system. So that's a system that might go from between a couple of different configurations and be able to move. We had a system called a flex that could be in a cave type environment where the two side walls were in next to you to make a cubic environment, but they were hinged at the seam at the center screen so they could open up to be a completely flat wall across the front. So if you needed a larger audience or you needed to do more of a flat wall type environment, then you could reconfigure the system as needed. Barco, of course, had a similar system as well that they had sold for a long time. You might have a curved displays. That was a curve that we did a long time ago at the University of Southern California there. Of course, Andrews mentioned the system they have there at Curtin, which is, they call it the Hive. There's been a number of systems called Hive, actually, in the oil and gas business as well. And you would have rear projection cube walls. So it's very similar to a flat panel array, except instead of using flat panel technology, you're actually using a rear projection cube. And actually, that's still a very useful technology to us just because they do still support stereo. So we can get a little bit narrower depth on it than a traditional rear projection display. But it's still available out there in full active stereo, so it's a very useful tool to create a visualization facility out of. You might have some compact or portable systems that you want to take the show on the road. You might have a portable system like that, or you might have some kind of specialized systems, something like a system to support consumer packaged goods. This is a system that we did for Kimberly-Clark. You may not know who Kimberly-Clark is, but you've probably used their products, and they are consumer packaged goods. They make diapers and tissues and a number of other types of consumer products like that. And this was a system in a facility where it was a combination of a virtual environment as well as the actual physical environment. They could actually, within 2 hours, they could completely pull a whole bunch of shelving units out that were the exact shelving units that Target used, and were all labeled with the exact same looking Target brand names, and they could very quickly pull in the exact same system for Walmart. And they would actually change the logo outside to a Walmart logo, and they could very quickly change that environment as they needed to, both physically as well as in a virtual environment. So that was a very unique type of facility as well. Advanced simulation environments, we did a system called the Wave, and that was for medical simulation. And that was actually kind of two circular rear projection systems connected by a hallway. So think of a dumbbell, and what they would do is they'd have soldiers kind of land in one spot, either in a Humvee type simulator or a helicopter type simulator, and then they would traverse the hallway to the other side where there was some traumatic injury involved in that side. And so that was, again, a combination of virtual reality from a stereoscopic projection type perspective, as well as actual physical props. They would actually hire individuals many of them were former military amputees, and they would actually put a kind of a prosthetic on there that was all bloodied up and gross, and would actually have motors in there that would make blood come out. And it was a tremendous experience, and it really, the idea was to help train military medics for a battlefield situation, and the more that they could make that realistic, to help them understand what that's like in a virtual environment, it makes that go much better when they actually reach it in a real world environment. And of course, the cylindrical tiled array is one of the newer things. Cave 2, you may have heard about, the University of Illinois Chicago. There's a number of Cave 2s that's gone in now. There's one in Australia, or actually a couple in Australia, and a number of other places around the world. And one of the new things that we're seeing are hybrid facilities. So a facility where you have location where HMDs can be used in a tracked environment so that you can have a number of individuals who are immersed in some type of simulation, all wearing HMDs. Meanwhile, you have a cave or some other large immersive display where people can kind of be watching, right? So they're the watchers, they're kind of understanding, trying to see what's going on. So as you have the individual doing some sort of training or drill or whatever it is that the virtual environment is, then you can kind of observe and see what it is from their perspective and see if you can gain new insights that way. So, and of course, you could have an HMD track space only, or increasingly, just a single HMD might be your visualization facility. So let's take a couple minutes and let's talk about what's next then. We have a whole bunch of different types of facilities, some commonalities among them, but what might be coming next? So one of the things that we're seeing is the rise of consumer HMDs. And this is mentioned many times. A lot of the research that I've seen presented so far are around how can we make various aspects of HMDs better, more realistic. Well, let's talk about what HMDs were. Of course, early HMDs were mounted to a counterbalance arm to hold them up. They were bulky, heavy, unwieldy, low resolution, and there was little software support for collaborative experiences. It was, of course, very much a single user experience. But we're seeing changes in that, many of which we've talked about here. Oculus Rift, HTC Vive, a number of other types of really, really common, popular solutions out there now for a single person HMD that are a very low budget point. And we're beginning to see a dramatic trend. And we're going to see, I'm sure we're going to see new pro models follow the consumer models as well. And I think we're expecting to see a much fewer large screen display systems coming up. It's a very hard, and we've heard it here as well. It's very hard to make here's your cave for $2 million or $500,000 or whatever it is, versus, hey, you can go buy a whole bunch of HMDs. And especially if we can find methodologies to make HMDs more collaborative, and to try and get more of that face-to-face, whatever it is that might look like, you're going to see fewer and fewer investment into the large screen types of facilities as well, versus facilities that are going to support HMDs. So likely you'll see facilities that are designed to make it safe to operate HMDs, so whatever that might mean. So you might have a number of people in an environment, all with HMDs on, of course, the inherent dangers with that. So what might you be able to do from a facilities perspective to make that a safer environment? I expect we're going to see some trends there as we move forward. How to enable collaborative exercises while wearing HMDs. How can you maintain as much of that collaborative feel as you can while still wearing an HMD? And systems that just accommodate mass positional tracking of HMDs in an environment. Another trend that I think we're going to see in visualization facilities is a continued move toward flat panel-based technologies. LCD flat panel displays, especially for high resolution 2D environments, this is pretty much the way to go. The bezels on those are getting ultra thin, and you're going to be able to get as much resolution as you want. You just tile up as many as you want, and you can have as much resolution as you want, and you're going to begin to see more and more 2D large screen arrays, especially for that type of visualization. The image-to-image gap is down to 1.7 millimeters. OLED, they're going to continue to grow in capability and lower in price. LG has a product that they're calling OLED wallpaper. It's a product that you can tile up to a certain extent. There's kind of a ribbon cable that's in behind it that makes it a little bit complicated to find a way to make them all array, but they certainly have done it. Big display at CES, if those of you who were there with the OLED wallpaper there. And so we're going to continue to see OLED make some trends. And then DirectView LED is another thing that we're going to see. Again, right now the price point is really high for DirectView LED, but it has extreme brightness, it has a very wide color gamut available to it. So there's a lot of advantages to DirectView LED that we're going to begin to see more and more of that, and especially as the prototype or as the pitch gets smaller. So for DirectView LED, the pitch, of course, is the distance between one pixel to the next. You can see prototypes out there as small as 0.7 millimeters or even smaller. And So the rule of thumb for a direct-view LED is you take the pitch in millimeters, and you take that times 10, and that's kind of the nominal minimal distance you should look at that display. So a 0.7 millimeter pitch, 7 feet away from that is your nominal distance. So you're really starting to get to the point where you can create a virtual environment out of a direct-view LED flat panel displays. One of the things you might see especially with direct-view LED are systems where you can have a lot more light, well-lit spaces, even maybe outdoor environments where you're going to be able to do some type of visualization in an outdoor environment if the need were to arise. And we are starting to see active stereoscopic views of those. We actually have one of those in our shop right now that we're demoing from Silicon Core, which is an active stereo version of a direct-view LED. So you're actually going to be able to do a full active stereo with those. And we're aware of 2 other manufacturers as well that are at least nominally offering a direct-view LED version of that. So from a facilities perspective, you might see some changes there. Flat panel technologies require much less space than projection, especially rear projection type technologies. You're less concerned with managing the room lighting. Projection, you gotta really be careful with room lighting when you have flat panel based technologies that are producing their own light. It's actually a much easier task to work with them in a well-lit space. Again, we talked about OLED wallpaper. I think that what they have now that they call OLED wallpaper is just only the beginning of what you might see down the road with OLED wallpaper, where it truly is literally something you can roll out as needed, and you can paste it up and make some connections, and you're going to have some amazing experiences there with the OLED wallpaper. Outdoor visualization systems, and one of the great things about LED systems is that they are very power efficient relative to their brightness. So what about projectors? So what I say up here is, projection is dead. Long live projection. We saw the stellar rise and fall of the 3D TV market over the last few years to the point where it's no longer in existence. There's one professional 3D flat panel still on the market from Planar. They have a Planar Clarity Matrix 3D, which is stereo. It's passive interlaced, line interlaced passive type 3D display that is available on the market. But largely, 3D flat panels are really hard to come by right now on an LCD type flat panel display. So in the meantime, projectors are going to have to come back and fill the void for any type of large visualization system until we can tell the price of direct view LED comes down, or we see other people get into the market with direct view or with LCD panels that are stereoscopic. From an image generator perspective, and I mentioned this earlier, one of the things that we're seeing is the desire to compact the image generator. For a long time, for larger systems, we were using a cluster of computers to create the required number of channels to get and the required amount of resolution to get. Now, of course, today, in theory at least, you could put as many as 4 Quadro cards in a single chassis. Each card has 4 outputs, and each output could be 4K. So theoretically, you could do 16 channels of full 4K, in many cases 3D as well. Now, whether that's actually feasible or not, I mean, it's technically possible. Now, whether it's functional or not is the better question. Do you have other bandwidth problems somewhere else in the computer chassis as far as buses or other things? But it's a growing trend, and we're going to see more and more single PC solutions to drive large systems as opposed to always being forced into a cluster type solution for driving those as an image generator. The other thing we're seeing is remoting of the image generator. Of course, it's very easy to do that now with any type of fiber optic or Cat5 type extenders. But where I really see this going is we're going to begin to more and more see a network-based. AV over IP is a growing trend, and I think you're really going to be able to see more and more video over IP. It's, the challenges, especially with stereoscopic, you have much higher bandwidths generally because you want to have higher frame rates. But I really do believe that, as they continue to make research on the compression algorithms, as higher speed networks become more affordable, as you see, as it becomes easy to make a 100 gig network, it's really going to be see some changes there. And finally, one of the other trends that, and this is my last slide, one of the other trends that we're seeing is a lot of collaboration among people who are operating visualization facilities. One such group is called the COV. It's the Higher Education Campus Alliance for Advanced Visualization. It's a really interactive group. They have, once a year, they get together. And these are basically people who are running visualization facilities at their respective organizations. And it's a great opportunity to find out, hey, what's working in your visualization facilities, what's not, and what can we do to make things better. So with that, I thank you very much.